So we already learned the basic expansion formula. There is another formula called the general formula. So the general formula is, like the name suggests, it will investigate a specific coefficient without going through all the expansion. So we can have, so this is the formula here. So this is called the general formula. So it's R plus one term. That means, right, if I would like the seventh term, then to me, R is a 6. So I can find a specific term. I can find like the 10th term. 10th term will be R equal to 9. Okay. So, or I can be finding like specific coefficient. So this is like a generalized situation. Okay, so how do we, let's look at the structure first. So basically, it will be quite neat as well if you take a look. It is A, B, and it's still power R. Can you see it still match the power? And the middle power is still something like n minus R. So that is in a general sense. Okay, so let's explore how do you use this. So most people find the general formula difficult. It involves a lot of technicality. So listen up carefully. So if you look at example 1, example 1 would like you to find the coefficient of x7. We don't have two brackets here. It's only a single bracket. But this single bracket has power 8. So that means, right, you can actually go on for your expansion. Okay, so you realize this is your A, B, and N. So if you have done your normal expansion, okay, if you're patient enough, you can go on to your normal expansion. So if you do your normal expansion, okay, if you're patient enough, you will get your coefficient of x7. But it's usually very long. You find yourself doing unnecessary steps. So that's where the general formula comes in. And in O-level, there are questions that need you to explain using general formula. Okay, so first of all, let's look at how you insert your A, B, N into the formula first. So make sure you realize what is your A, what's your B, and what's your N. So nothing tricky, just insert. Okay, upon this, you successfully use the formula. It is a simplifying that most people cannot do. You are supposed to simplify in such a way that you will end up something like this. So this is the part with no x. This is the power of x. You will have x here. And this part is what we'll call the coefficient. So you have to simplify until you got to separate out the x and the non-x. So that is the challenge part. A lot of people get challenged by it, especially if you're not the kind, if you're the kind who don't do step by step. So if you look right, this to me is no x. This, there is a x, and I need to simplify. So I need to simplify using my indices. Multiply the power. Okay, but the last bracket got a number and x as well. So I got to apply a bit of indices. So you got to recognize that 1 over x is x minus 1. So that's why there's a little bit of indices here. Then after that, remember your job is to split out. Okay, so let's try to split out. So a lot of people will miss this part. Listen up carefully. power R is for everything in the bracket. So give the power R to 2, give the power R to X. Give the power R to 2, give the power R to X. Okay, then remember your objective. Your objective is to combine all your X. So this is your same base multiplication. So same base multiplication. And this part got no X. This part got no X. Can you observe the no X? They got no X. And the X, so I should be adding up these two because it's same base multiplication. So I will add that up. So there are some amount of indices. So don't be tricked by it. Can you think logically, step by step? Or else you will be easily confused. So at the end of it, did you see this part? This is the one with no X. This is the X, and this is the power of X. And what are we interested in? So you take a look at what are we interested in. We are interested in the coefficient of X7. Do you realize that the power is 7? So which means, right, you should have set this to 7. And you will get a nice number. You put the nice number into the part with no X. Coefficient is the part with no X. This part. You put it in this part. And you punch calculator. So this is the coefficient that we want. Okay, so what is the implication of all this? So this happened at R equal to 3. That means, right, when it is the fourth term of the expansion is coefficient of X squared. That means, right, the fourth term is going to be 448 X squared. So we use the general term, we use the power in the general term to help us to find a specific R. The R is meant for you to sub into the coefficient part so that you can punch out calculator. So in your general term, there should be a coefficient part, there should be a X, and there should be a power of X. So the coefficient part, in short, it will be the part with no X. So it's a X versus no X concept in your general term. So if you couldn't get this clear, you'll find general term very difficult. So when do you use a general term? You use it when we are only interested in finding one specific coefficient in a single expansion.